everyone, welcome to Line by Line Coding Tutorials. My name is Jonathan, and today we are covering closure in JavaScript. Okay, so let's go ahead and check out how closure in JavaScript works. This is a pretty notorious topic for a lot of people. It was difficult for me when I first started coding and understanding it. It really took a while and some good explanations for me to understand. So if you guys don't get it right off the bat, don't worry about it. There's still a lot of people in the field working right now that don't really understand it very well or understand what's going on in the background. But hopefully this example and these steps that we go through can really show you guys how closure works and how powerful it is to use. Because this is one thing that is absolutely fundamental to JavaScript, and you should definitely know this to heart because it can help you so much and it can do so many things. So I'm really excited that we're going to go over this topic, and hopefully these examples can make it clear for you guys on how closure works. So let's go ahead and get started. All right, before we jump into closure, I wanted to go over a couple topics that can make it a lot easier to understand what's going on with closure. A lot of tutorials and videos tend to skip over these topics, which in my opinion makes it harder to really understand what's going on with closure. And I think that's why a lot of people think it's such a difficult topic to learn. So hopefully when we go over the call stack and execution context, you guys can really understand how it's working. So first of all, we're going to go with the call stack. Now, the call stack is a way of arranging data, especially when we're talking when we're running our program. So for instance, we have three basic functions here. We have the dog function, giraffe function, and a cat function. When I'm saying this out loud, it kind of makes it seem so simple, and their names are kind of goofy. So we're going to roll with it though. So we have three basic functions, really simple, right? We're just console.logging each one. And as we step through that, what would be happening here in the call stack? Well, when the execution dog function down here runs, main will start. So the main thread is what is always going to run no matter what. We're going to have the main thread, which then finds the dog function, gets pushed onto the call stack. Then we would be executing dog's rule up here. After that, dog function is popped off of the call stack, and the giraffe function is called, gets pushed on the call stack, console.logs, giraffe's rule, and it gets popped off. Same thing with the cat function, pushed onto the call stack, gets popped off the call stack. So when we're working with the call stack, it's really important to know what's happening with the data in between those brackets. So when I'm talking about execution context right now, this example, what I'm going to show you, the execution context for the cat function is going to be essentially in between the brackets. It's where the state lives, or the data, the local memory, or the environment for that function's execution context. So we don't have any data or anything stored in these functions, but the console.log is in the execution context of those functions. So every time a function finishes executing and it's popped off the call stack, all of its local memory is deleted except for the return value, which we'll go over later. Right here, after this, well, we don't have data here, but after this is done executing, if we had a variable here or whatsoever, we wouldn't have any data or state between executions. It's just clear, right? Because we pop it off the call stack. And it's really important to know this because closure allows us to essentially cache and have persistent memory when we're working with the execution context of functions. But it starts with us returning a function from another function. And that's kind of what tricks people and kind of makes it a confusing topic. So let's go ahead and jump into the next example. And then, of course, main stop running there, and that would be the end of that. Okay, so here we change up the arrangement of the functions a little bit. You can see here we have the basic function still, but instead we're just calling dog function, and then inside of the dog function we're calling giraffe. Inside of the giraffe function we're calling the cat function. It sounds so funny saying those, giraffe, dog, and cat. So I want you guys to think what would happen. What would the console.log order of this be before I continue? So pause the video and think about in which order these cats rule, giraffes rule, dogs rule, whichever, how those console.logs would show up in the console in what order. Okay, so let's step through and see what happens. So we're running the dog function first, right? Dog function gets popped onto the call stack or pushed onto the call stack. Then we're inside the execution context of the dog function, right? The local place where we have it, and we are calling the giraffe function. So giraffe function gets called, and now we're in the execution context of the giraffe function. And then the cat function gets called because it's the first line here in the function. Cat function gets called, and then we would be console.logging cat's rule. So cat's rule would be the first thing to get logged in the console. Cat function gets popped off the stack. There's nothing else running in the function. We return to the giraffe function, which will then console.log giraffe's rule. Giraffe function is popped off. And then that's the last line of that function in that execution context. There's nothing else left. So we are popping giraffe off. Now we are back at the dog function and we are running this console.log dog's rule. So then in the console, it would be dog's rule. So the order would be cat's rule, then it would be giraffe's rule, and then it would be dog's rule, which can seem very confusing for people because we're calling the dog function first, and then we have this console.log here. So people would think sometimes it would be dog's rule that would be going first. But no, it's actually cat's rule because we are entering the execution context. We're calling these functions. So once we hit this, we're calling that. We're into the giraffe, hitting this cat function, calling it. So we're going into the cat function. And that really, hopefully, can drill in how the call stack works, execution context, which we'll go over a little bit more, especially in this example. So in this one definitely looks a little goofy, especially if you're just starting out. We have a function called announce, takes in a name. A return a function takes in sound, and we're simply console.logging it. My name is whatever we put the name in, and I, whatever the sound is. So this is just an anonymous function here, just returning an anonymous function. And then down below, we are setting announcement equal to announce with the name set to Maddie right here. So we're making announcement equal to announce, right? So main thread runs. We are now calling this announcement right. Or I'm sorry, not yet. We're still on the our announcement. Main thread runs, announce is pushed onto the call stack, right? Because we are calling it right here, equals announce Maddie. We're indicating we're calling it right here. Passing in the name as Maddie, right? Announce is done at that point. We are returning this function. That's essentially all that we're doing in this line, or in this function. We were returning function. And that function is an anonymous function which takes in sound and then console.log something. But notice here, we are saving this name variable. Not a variable, sorry, this name parameter or argument as Maddie, what we entered in. There's no name here or anything, variable name. This is just one example. Typically you would have maybe like a variable name equals whatever the name would be the same thing. But for this one, we're just simply using the argument. So we're popping that off, but this name variable is still going to be able to be accessed by announcement. Run this part right here. And that's because of closure. Closure allows us to keep this data, this preserved data. That's like the way I like to think about it, is closure is preserved data. And I kind of think of it as like a little magic bag that holds this data that surrounds the function of it. And this name, this Maddie name, is saved. So when we call announcement now, announcement is equal to what? I want you guys to answer this before we continue in your heads. Try to figure it out. What is announcement equal to? We check this out here. Our announcement is equal to announce, pass in a name variable, and then we simply return a function. right? Remember when I said earlier, when the function finishes executing, its local memory is deleted, except for the returned value. Returned value is an anonymous function. So, announcement is called. We still have access to this name Maddie because of closure. Think about it. It's just a little magic bag that keeps that data preserved. And when we console.log this, we will be passing in bark here. And my name is Maddie and I bark. And hopefully that can help you guys understand. I know it's tricky, especially when you're starting out. But don't worry, this is a notorious topic and people have problems with it. The best thing you can do is practice, go over examples, look at examples, try to really understand. Takeaway here is that closure is preserved data. Think about it like that. And in the next segment of this tutorial, I'll be doing a whiteboard showing you an example. And then after that, I have a really good code example, which will show you how closure works and the surround, you know how I said earlier, things that are surrounded perhaps by the function get pulled in. They're manipulated inside the function or changed inside that inner function. I know this is a difficult example because this is an anonymous function, but later on in the video, the coding example will really help you guys understand how closure works. So hopefully this helped you a bit. I just want to reiterate here that when we're returning something, for instance here, function I want ABC, return just ABC, a simple string, right? Do const test is equal to that function. And then we console.log that. That's just going to be ABC. Think about it up here. It's the same thing. Our announcement is equal to the announce function. Here, instead of returning a string, we're returning a function. So announcement is going to be equal to that function. All right, everyone, I wanted to show you guys something a little bit different. I wanted to show you guys a whiteboard example of how closure works and go through it step by step. Someone showed me this a long time ago, and it really helped me understand what's going on with closure. And I feel like sharing this with you guys might help some of you. So hopefully this can help you guys really understand what's going on step by step in closure and give you a good idea of what's happening. So let's go ahead and jump through this. I just want to point out here on the left, we have the lines as if we are writing in a text editor, just to be able to point out things a little bit easier for you guys. So we have line 1, 2, 3, 4, 5, 6, all the way to 9. Nothing crazy there. All right, so let's go ahead and jump into what's happening if we were to execute this program right here. We have a function called outer. Simple function, declaring a variable number equal to 0. Then we're declaring another function called inner. Inside of that inner function, we are simply making the number increase by 1 each time it would be run. And below that, we are simply returning that inner function. Then we have var blah is equal to the outer function. And then blah, we're simply calling it on line 9. So let's jump in and see what's happening. Right now, first step, what's happening? Outer is set in global memory to what? It is set to a function, right? Outer is equal to a function. First thing, we're saying outer equal to a function because that's what it is, right? Look, nothing too crazy so far. So now what we're doing here is we're setting variable blah, right? We set the variable, set the outer function. Now next would be line 8. So we're going blah is equal to what? Well, we're about to find out. Stepping into blah right here, right? Saying blah equal to founder. Or outer, sorry, not founder. So down in our call stack, add outer. We are running it right here. I'm going to set the local memory. Hopefully you guys can see this still. Do outer, or I'm sorry, not outer, blah equal to outer. And we're going to have this represent our local memory, right? We're step in. It says local memory. Hopefully you guys could read that. Yeah, it's legible. All right, so we're in local memory here in blah, right? See, we have it on the call stack. Don't forget about that, guys. It's really important. We are inside the execution context of outer function. We're going to go ahead and set. What's next? It's going to be line 2. We're going to be setting variable number equal to 0. And then we're going to be declaring inner as a function, right? Local memory. We're just in the local memory of the outer function. That's what we're doing. Variable number equals 0, and inner is equal to a function. So we are returning this inner function. This is the last thing that's running in the outer function, right? So when we're returning anything in a function, it's whatever value or a string or number or whatever you want it to be. In this case, we're returning a function. So whatever we're storing that value in is going to be equal to whatever that value is. In this case, it's blah, and that's equal to a function. So we're returning inner right here, right? So if we're returning this function, right, this is the last line. We're going to be Xing out of the local memory of this this outer function, right? I'm going to go ahead and take this. I'm going to put it right here for right now. This is done. We're out right here. And we can actually go ahead and pop this off the stack, no longer in that context of it. So what now? Blah is going to be equal to what? We're out of this. We have this function right here that it returned. Think about it real quick. It's going to be equal to, what is it? It's going to be equal to inner. That is a function. Hopefully you guys can see that. I'm going to put it right here. Inner. Here for you guys. So inner is equal to a function because we returned it right here, right? Or I'm sorry, inner is not equal. Blah is equal to a function, right? Return inner, var blah equals outer. Call the thing. We went through the step, set the variable number equal to 0. Inner is equal to a function, and we're returning that inner, which is a function. So blah is going to be equal to that inner function. Hopefully that makes a little bit of sense for you guys. We are outside of this local memory scope. We are just, that's gone, right? Now we are hitting line 9. Up next, we're calling blah. What happens when we call blah? Well, we're going to do local memory. We're going to do blah. Throw it up. It's going to be blah is equal to inner, right? So we're going to do blah. So we essentially said we're putting inner on the call stack, the inner function on the call stack. I just want to be that clear. So local memory for blah, which is equal to inner. Inner. We're going to be looking for number plus plus. So that says number plus plus. If you guys remember that from right here on line 4, we're using the inner function. Hopefully that's a little clear. So this is what tricks people the most, right? If we were talking about scope, lexical scope, variable scope, in my past video I did an example on this. We would be going outside of this, or right here on line 4, we would look for number, right? Because we're trying to increase it by 1. Well, we wouldn't find it in the inner function. So what would we do? We would look for it in the global scope. I'm sorry, not the global scope. The outer lexical environment of the inner function, which would be here. It would find it on line 2. That's how it works. But in this case, right here, behind the scenes, what's happening is this is gone, right? We don't have outer's gone. We don't have access to this number or all the other variables that could be inside of it. We're outside of the execution context. So where do we get number variable? Well, we got to increment it right here, right? Because we called it. So what happens? Well, this is what closure is. Think of it as preserved data. Preserved data. That's probably the best way of explaining it.
It really helped me understand. So we're going to be looking for number here in the local scope of inner. We're not going to find it, right? So not getting it there. And we're going to go ahead and go up here. We're going to go look for it. Well, we're not going to find it at outer because that's gone. That's not, we're not even in that land anymore. What's going to happen? Well, closure. Think of it as like a little bag of data that gets preserved, and number is going to be preserved there. That's it. That's all. We're going to have data. That's its data and number. I'm trying to draw a picture of a bag, but it didn't really work. We're going to find that in closure. The scope of outer variable. I'm sorry, not the outer variable, but the outer function. It's really important to know this, and hopefully this makes sense to you guys. I know it could be a really difficult concept to understand, especially when you're starting out. And then, of course, this would actually be popped off as well. So what I want you guys to take from this is that just because we are no longer using this local memory of the outer function, just because that's popped off the call stack and that variable number isn't to be found, that context of outer doesn't mean we don't have access to that, because closure enables us to have access to those variables or whatever data is there. And hopefully in the next video, I'll show you a quick example. We can go inside the function itself and really see what's happening behind the scenes. And I'm trying to think if there's really anything else to explain to you guys other than what I showed you. The most confusing thing is thinking of it as this part right here, like kind of like around here, all the stuff around it, I guess you could say, this inner function would be considered closure, right? Because it's in the scope of the outer environment, and it has access to that after the execution. Because closure, I know it can be a lot to explain, but it kind of sucks all of this out and puts it in like a secret little bag, magic little bag that gives you access to these variables or whatever data you have with that function or inside that function. So hopefully that helps you guys out a little bit. The next video will really drill it down for you guys. I hope you guys enjoyed this. So let's go on to the next step and see what this looks like actually inside the code.
All right, so this example right here hopefully drills it down for you guys and understand what closure is and how it works. We're simply going to go through this basic function step by step, and this should hopefully help you guys understand what's going on. I love this example. This really helped me a long time ago. So we're going to go ahead and just go through this. We have a function called counter, which has a variable number equal 0. Inside of that, we declare another function called increase number. That simply increases the number value by 1 each time it's called. Return this increased number function. That's it. Below that, we declare a variable, my new function is equal to counter. And below that, we run my new function. So the best way to show closure, in my opinion, is this. Check this out. We have var number here is equal to 0, and we're manipulating it in here. What happens if we console.log? We don't want caps. Arguments. Let's see what happens. Here we get arguments. Look at this. Go down to scope, closure, number 1. Pretty cool, right? You get to see the closure itself. Number is 1. That's in the scopes callee if you console.log arguments. So what's happening here? Well, we're manipulating this number plus in here, so you're getting access to it up here, even though this execution context isn't being run. We can do this, or I'm sorry, we're exiting out of that execution context to show you this here. We still have access to it though, just console.log number. I'm sorry, this has to be, that actually shows it too, why it wouldn't work. We had the console.log out here. We're not in the counter every time we run this function, right? Just for the first time, initial setting of counter when we run it, number is 0. Here, actually, I'm gonna go back and show that. So look at this. Maybe this will help you guys understand. When we run this, right, save that, we're getting 0 in the console, right? Refresh this. This is because when we set this variable myNewFunction equal to counter, we're running it right here. It's going to be equal to 0. We're console.logging it here, and then we're simply returning an increased number. And this isn't running because we're simply returning this and setting myNewFunction equal to the return value, which is a function called increased number. So myNewFunction is equal to increased number by the end of this counter function running, right? If we were to put console.log number in here, we wouldn't get anything. I'm sorry. I'm running it down below. We wouldn't get anything because it's not running, right? We're simply returning this function. This function is not running here. We're just getting the return value of counter. Now if we were here, we would of course get it because counter is running here. So those two parentheses. But increased number is not running. So hopefully you guys can understand that, right? We're simply running the function, returning this because we're returning it here, and now myNewFunction is going to be equal to that return value, which is increase number. Now don't forget, remember when I said earlier that all state or data is lost after the execution context. So this is essentially something like bar number or whatever we have in here. A closure allows us to keep that because we're putting another function inside this function here. So let me show you. We do these two, we call it twice. myNewFunction is going to be equal to the increased number right here. We still have access. Number. Still have access to number 1, 2. Right? Pretty interesting. Now check this out. Let's say we have something like this. Const a C. Something maybe down here. Console.log, or let's do bar test equals. Whoa, this is cool. What would happen here if I don't have anything inside of this increased number? I do console.log arguments to check out the closure, what data we have available. Remember when I showed you earlier when we console.log arguments, you're able to go into the callee and then to the scope. We're able to see the number 0 in there. What happens now? What do you think you guys are going to see since we added this myArray and test? Do you guys think we're going to be able to see it? Well, let's look. Don't need to run it multiple times. Just need to run it once. So we go to callee, check out scope, and closure. Oh, we're only getting the number 1. Did you guys think that we would be getting myArray test as well? Well, not, because we are not in the they're not in the execution context of this increased number. This is really important right here. These aren't part of the closure because they're not, number is being referenced right here, right? So this is a part of the closure because we're manipulating it, it's inside the function, we're having a reference to it. MyArray and test, they're not part of this execution context, so it doesn't even know that those exist. Now if we were to do this, let's do myArray.push D. I'll do this one first. Just below that. Now we're simply pushing D onto the end, so this should be ABCD. What do you think is going to happen? Well, we have a reference to myArray here. It's inside of this execution context, and it sees it up here. So if we go ahead and console.log this, go to Collie, scope, closure. There we go. We have myArray, A, B, C, and D. It's pretty cool, right? Now if we were to have tests in here, test equals, wow, it changed. What do you guys think is going to happen? I think you guys know. Go into the console.log, check it out. Here we go. Wow, it changed. We have a reference to it inside of this execution context. So hopefully that helped you guys out understanding closure a little bit more. If you don't get it the first time, don't worry about it. It's a difficult topic. Just try as much as you can to understand this because it is so powerful and it's used so much, especially in functional programming. We're using map and reduce and all these cool functions and methods. It's really important to know. So hopefully you guys enjoyed this video. If you have any questions, leave a comment, or if you want any other examples, let me know. I'd be happy to help you guys. And once again, thank you guys so much for watching my videos, and I hope you have a good day.